Welcome to a new lesson. In this lesson, we'll be exploring parallel lines. Let's first define what parallel lines are. Parallel lines are lines that go infinitely left and right or up and down and will never intersect, will never touch. For example, these two black lines. They will go forever to the right and to the left in this case, and it will never intersect. This means that the distance between these two lines is always going to be the same, and it will never change. That's the definition of a parallel line. Parallel lines. There are other definitions that need to be discussed with parallel lines. The first is the transversal. The transversal is a line that intersects parallel lines. The next one is the interior angles. Notice that we have two blue parallel lines, and that there's a transversal, which is right here. This is the transversal line, and it creates four angles, 1, 2, and 3, and 4. Those angles are called interior angles because they are trapped between the two parallel lines. The next definition is corresponding angles. So the corresponding angles are created by one being inside the parallel lines and one outside. Another way to explain it using the F shortcut. The F shortcut, as you draw it like this, shows that the corresponding angles are created between the two parallel lines, as well as one below the parallel line. And the last definition is the exterior angles. Exterior angles are the angles that are created outside of the parallel lines with the transversal. Before we continue talking about parallel lines, we need to talk about vertical angles, or opposite angle theorem. Now, suppose that we have one of the parallel lines, and we have a transversal. So this is your transversal. And there are four angles that are created, like so. The vertical angles are created are the red and the green. These are called vertical angles or opposite angles. This means that the red angles are the same and the green angles are the same. They're opposite from each other, or they're vertical from each other. The next thing that I want to discuss is the corresponding angles, or the F rule for short. When we have parallel lines, we have a transversal. Again, remember, transversal is the line that crosses both the parallel lines. For this F rule, I'm going to be showing how A and E are related to each other. Now let's draw this F. Now in this case, we can draw this upside down. Notice that the angles have the same patterns. As well as another F right there. Now sometimes this F is upside down, sometimes it's reversed or inverted, but all of these angles are positioned so that they are corresponding. And the F rule shows that they're pretty much the same pattern in this F shape. And since they are in this F shape and they form this F pattern, they're called corresponding angles. Therefore, these angles equal in parallel lines. The next rule is the interior alternative angles. Now these are two parallel lines that they do not have a transversal. So I'm just going to write a transversal. And I'm going to show you the Z pattern. So I'm just going to change the line. Now notice the Z. I'm going to draw this in black, not black but blue. And I'm going to show you the interior alternate angles. So here's one interior alternate angle, and so is the other. These two angles will be equal. Also, because of the Z pattern, and I'm going to draw the reverse Z for this. It's a funny kind of looking reverse Z. Also, these interior angles also equal. We knew that these angles equal in the previous little example, and now the red angles also are equivalent, and they're also called interior alternative. They're also called interior alternative because they're inside the parallel lines, but they're also on the opposite sides of the transversal. The last thing I want to be discussing with you is the supplementary angles. And let's go back to the F pattern that we discussed. So here's your transversal line, and here is the F pattern. So notice that these are corresponding angles, and but they're not supplementary. They do not add up. They do not equal, or they sum up to 180. They're just equal. But there are two angles inside this F figure that add up to 180. And I'm going to show you which angles are those. These are the interior angles. They add up to 180. So for example, if this was 110 degrees, the blue would be 70 degrees. 70 plus 110 is plus 70 is 180. Also, this happens on the opposite side of the transversal with these two angles. Notice that this also has to be 70. It's interior alternative and also supplementary of 110. And this is going to be, of course, 110 because it's interior alternative with 110. And 70 and 110 on the other side also have to equal to 180. Now, using all this information, supplementary angles, corresponding angles, interior alternative angles, let's solve the next example. So find the value of all the angles and explain your reasoning. So first we have to find the value of all the angles A, B, C, D, E, F, and G, and as well as the reason for the value. So basically it's saying, how did you solve for this angle? Let's first recognize the parallel lines. The first parallel line is this one, and here's your pair. We're usually given an angle. In this case, we know it's 140. And there's a couple of things that we could discuss. Opposite angles, interior alternative, and corresponding angles. There's Z and the F rules for shortcut. The first thing I'm going to solve is for A. And A is fairly straightforward. It is the difference between 180 and 140. So it is 40 degrees. 180 minus 140 is 40. And the reason for that is that if you draw this straight line like this is a straight line, we know one of the angles is 140, and the missing angle has to add up to 180 degrees, the definition of a straight line. And that rule is called supplementary. So here we go. Supplementary angles is the reason for angle A to be 140. So now I'm going to erase these, and I'm going to leave A as 100, and it's just 40, not 140. The next part is we know there's a relationship between A and B. I mean, one thing you could do is you could say that A and B is on a straight line, so B has to be 140 degrees because 40, which is A, and B are supplementary angles. Or another way you could solve for B is to recognize my favorite rule, which is the opposite angle theorem, or the vertical angles. That 40 is opposite to B. Sorry, 140 is opposite to B. Therefore, B has to be 140. And this is vertical angles. You could also say 140 and its supplementary angle to 40. The next part is, what about C? So this is 140. How is C related? Well, C is opposite to A. So that means, or vertical to A, that means C has to be 40 as well. And because of vertical angles. Now, all these three angles are solved just by knowing supplementary angles and the vertical angles. But we haven't really discussed yet the rules of parallel lines and the angles related to these parallel lines. So let's again discuss the parallel lines. Here's your parallel line, and here is the transversal line that intersects both parallel lines. And now let's try to see the Z or reverse Z or F letters. And my favorite, of course, is Z, so I'm going to draw that Z line, or reverse Z. And I notice that there is interior alternate angles between C and D. Therefore, right away, I know that D is 40. And the reason for it, because I see that reverse Z pattern, and that's interior or alternate angles. Also, I could take a look, and I see that 140 and E are also interior alternative angles, and therefore E is going to be 140. They're also interior because they're inside the parallel lines, and they alternate. That means they are on the opposite side of the transversal line. Now, for F and G, we could use the opposite rules. We know that G is going to be opposite 40, and we know that F is going to be opposite to 140 degrees. But I'd rather use the F rules now, because we have another opportunity to solve a problem using the parallel lines. Now, recall that for corresponding angles, we're looking for the F pattern. And these are the two angles that are corresponding, therefore they are equal to each other. So G also will be equal to F because of the 40 degrees. G will equal to C because of the 40 degrees. And it's called corresponding angles. And I've written down in the wrong section, but that's okay, I'll fix it. So G is 40 because of corresponding angles. And last one, F. F is also a corresponding angle. If we draw a little bit flipped F, in this case it's going to look like a 7. Well, sort of looks like a 7. There we go. Therefore, this angle right there, 140, and F are corresponding angles. So 140 is equal to F because of corresponding. And make sure you write the word angle, but I don't have much space, so you'll have to forgive me. So there's one more definition that I want you to learn, is the word converse. It's a statement that is formed by switching the premises and the conclusion of another statement. Now, so far, I've taught you that if we have two parallel lines, so here they are, we have a transversal, and since we have two parallel lines, the interior alternative angles, so let's just draw the Z pattern. Here they are. I'm going to redraw this because it doesn't look very nice. So here are the angles, these two angles, and let's call them, this is interior alternate. They are equivalent. So the statement would be, is that, so here is the statement. That's a funny looking A. It's not a Q. If you have parallel lines, then interior alternate angles will equal. Now what a converse to this is, if the interior alternate angles equal, then you will have parallel lines. You see how the statement has switched? Initially we have parallel lines. If we have parallel lines, then we have interior angles that are equal. But if we have interior angles that are equal, then we have parallel lines. So initially we started off in this example with having a transversal, and I said to you that we had parallel lines. Because we had parallel lines, we know that interior angles, these two angles, will equal. But now we're saying, okay, we don't know if these two lines are parallel. If we draw a transversal, does not mean it's parallel. So we know that these two angles are equal because let's say we measured it. Let's say these are 40 degrees. Therefore, we have to conclude these lines have to be parallel. And that's what these arrows indicate, that these lines go on forever and ever and ever and never touch. So here's a little example for you when we use the converse of parallel lines. Are these lines parallel? So we don't know if these parallels or not. But we know there are two angles, 120 and 140. From the rules that I've showed you earlier, we know that there's a relationship between 120 and 40. They're interior angles. They're not interior alternative, but they are interior angles, and they're facing each other. These angles are supposed to be supplementary. So here's a little question mark for you, supplementary. So do they add up to 180? Well, let's add them up. 120 plus 40 adds up to 160. Since they are not supplementary, therefore it means that it is equal to not parallel. And that's the solution. If they would add up to 180, then they would constitute a supplementary angles, and therefore the two lines would be parallel. So the lines are not parallel because of this.